This is Clinton P. Kui again with another video. As you can tell by the title, we are going to be finding the value of a constant in a solution to a particular differential equation. That's what I'm going to be doing in this video. So let's go directly. The function defined by the equation xy minus the ln of y equals to 1 satisfied this differential equation. X bracket open y prime prime plus y prime all square minus y prime prime plus k y prime equals 0. Find the value of k. So in a nutshell, this question is about finding the solution to finding a differential equation that represents this solution and then comparing it with this to see what will be the value of k. That is what the question is about. So the first thing we do is just to begin with the function given. We begin with xy minus ln of y equal to 1. We begin with this, and because in this particular differential equation we have the second derivative, we have to differentiate twice. So let's go and differentiate the first time. So we all have sy here, so I'm going to use the product rule. Product rule says if you differentiate the first term, the derivative of x with respect to x is 1. We hold y constant plus we hold s constant and differentiate y, that's y prime, minus the derivative of ln of y is 1 over y times the derivative of y, which is y prime, equal to the derivative of 1 is 0. So that's the first derivative. We can just go right ahead and simplify. 1 times y is y plus x times y prime is xy prime minus 1 times y prime is y prime and then divided by y. Everything equals 0. Now this is a fractional equation, so we need to get rid of the fraction by doing something very important, and that is by multiplying by the least common denominator. So the least common denominator here is y, so we multiply this entire thing by y. So we have y plus x y prime minus y prime over y equal to 0. And let's see what we have. Y times y is y squared. Y multiplied by x y prime. What is y times x y prime? Is plus x y prime minus y and y are going to cancel out. We're just going to have y prime equal to 0. So that's what we're going to have. Once we have that, we can move on to differentiate for the second time, because as I said, the differential equation given has two, or as the order, so it has the second order there, or the highest order there is the second derivative. So differentiate for the second time. Differentiate y squared is 2y y prime. Great. Power by coefficient, and then we use chain rule. Now we have three expressions here, x, y prime. So these are products, right? Three expressions have been multiplied. So what we do is we use the product rule. We differentiate x, that's 1, and then we hold y prime constant, y prime constant, plus we hold x y prime constant, and then we differentiate y, that's y prime. Remember we are holding this y prime constant, and then plus we hold s y constant and differentiate y prime, that's y prime prime, minus the derivative of this y prime is y prime prime, everything is equal to 0. So we can move on to simplify. We have 2y prime plus 1 times the entire expression is the same y prime, plus this is going to give us x y prime all square plus x y prime prime minus y prime prime equal to 0. Great, we collect like terms. 2y prime plus y prime. Remember the coefficient of this is 1. So 2y prime plus 1y prime is 3y prime plus. Now I can rewrite this. I can bring x y prime first, and then I rewrite x y prime all square. So I just brought this one first and write it on second, minus y prime equal to 0. So in this case, rearranging will not be a problem because remember, I wanted to resemble this form. So I bring these two expressions first. X y y prime plus x y prime all square minus y, this prime prime, minus y prime prime plus 3y prime equal to 0. I brought these two first, and then I brought this one second, and then I brought this one the last. So this 3y y prime. Great. So I can factor out an x in the first two terms there. I can factor out an x in the first two terms there. And what do you think I'm going to actually have? If I factor out an x, I'm going to have x bracket open. Here is going to remain y prime plus what's going to happen right here. Right here I'm going to have y prime all square, and then I have a minus. Remember, I have a minus y prime there. So this closes minus y prime prime plus 3y prime equal to 0. Plus 3y prime equal to 0. Now, once I have done that, I have to realize something right here. Right over here, I have x, y prime prime. So this should have been x, y prime prime when I was rewriting it. X, y prime prime. So this prime prime. So the problem came from right here when we were rewriting this. So we need to write this and then write this. So that's it. You know, the logic is flowing. So we compare this with the original equation given. We compare the both of them. Compare that with the original equation given. What will we have? So as I rightly said, here we had an x, y prime prime from the derivative of this last expression I will have here. So we brought this down, so we rearrange this scheme and then this, and then when we write this we have to factor out an x. So factor out an x, we have y prime prime plus y prime all square. So compare this with this. We are seeing an x, we are also seeing an x. Y prime prime plus y prime all square, y prime all square minus y prime prime plus k y prime plus 3y, oh, I'm always forgetting, plus 3y prime equals to 0. So we compare, we see that k is equals to 3 because the rest of the other things are equal. Therefore k equals 3 if you compare. Thank you very much for watching and see you in our next video. Wow.